Hey guys, Easy Science here. Studying for an exam or just learning for fun, you've come to the right place. Okay guys, sorry I've been having lots of work at school, so now I'm coming back and making lots of videos. At least once every 3 days, I'll try. And I've gotten some science classes in so I can review some stuff from there too. Okay guys, now into the video. So today's topic is on electric current and electrical resistance. So, it's about electricity, but what exactly are these things? You've probably heard of them, but don't know what they mean. I'll explain right now. As we see, right here is a circuit, a simple circuit. A circuit is an electrical, it's basically like a racetrack. A circuit right here, let's say this is a circuit, the starting line and the finish line. And you have to wrap around, or here, let's say that's the start and finish line. You have to run around, so let's say 3, 2, 1. You run around, and you run right back where you started. So that is a circuit, as we see in races. Right here is also a circuit. It resembles one too. As we see, the battery provides energy, and the load is what takes up energy, consumes energy. Okay, so now, what is a battery? Well, we've seen batteries like in our RC car or mouse. They provide power, but it's basically multiple cells. Cells are electrical cells which have a voltage, which I'll explain later, and just provide electricity. And they are put together to provide certain power that powers the circuit. A load is basically a component or portion that consumes electricity. The battery is basically the food or your meal. Multiple cells are basically your dinner plates of food, and the battery itself is the meal you're eating. The load is your backpack that you walk to school. Let's say you're walking around school, or let's say here, this is your school as I go to school, and this is your house, right? The path is pretty far and you have to walk there, but then you're added a 2 kilogram backpack. Well, you have a 2 kilogram extra load basically that you have to carry around and use more energy to have on you. Like here it says that consumes energy, or electricity in this case, but in our case it's energy. It's basically the same thing because you could transfer electricity into energy. Now back to the circuit. We know that, or here, there's two sides. A polar is something that has, like our Earth, has two sides, like the top and the bottom, each one with an electrical charge. Our Earth has the North Pole and South Pole. Here, the poles are positive and negative. The current moves from negative to positive. What is the current? Electricity is made up of electrons with direction, negative and positive direction. Electric current is basically the flow of electrons. As we see, the electron flow goes from negative to positive. This can be seen as the current, like a current of water. Or let's say you're walking in the mall, and you're going from the Sears, or another type of store, to Target, let's say. And it's pretty crowded in the mall, and you have to get there quick. How fast? Let's say you have a group of buddies with you, and those are, you could say, electrons. So this is the mall hallway, and your buddies, electrons, and you're trying to get from A to B. As you go or run, that is the flow. Your flow is basically the flow of electric charge. Let me write that down here. Flow of, so what is it? Current, electric current. is the flow of electric charge. Do you guys know what electric charge is? Well, as with our polar battery or atoms, or let's say, electrons have a negative charge and protons have a positive charge. That's basically the same thing here, but with direction. Okay, two more. Now the next concept, electrical resistance. A conductor, we need that to know. A conductor is what conducts electricity. In this case, the copper wire that is used with the electric charge direction pointing with arrows. So let's go back to the mall example. Resistance. What is that? Well, in a circuit we need resistance, or else current is going to flow very fast. And it measures the difficulty of the passing electric current, or measure of difficulty. So let's say our resistance, we can say in our mall, instead of our buddies just running through the mall as fast as they can, which, as we've heard, short circuiting. You've probably heard that. I'll explain later. So let's say in our mall, it's a bit longer, but now there's a ton of people in there. It's Black Friday. We have a bunch of people here. Now our buddies have to maneuver through the people, which takes away how fast they're going to get to the mall, which gives them difficulty. Same thing in the circuit. Resistors are added so that the circuit doesn't move too fast, or current doesn't move too fast through the circuit. A resistor could be in the load like a light bulb. When you pass through the light bulb, at least through one of them, there's a resistor, and when it resists, the electricity gets resist, it releases heat and energy and light, which then can be transferred into like how a light bulb works. So a short circuit, like we've been talking about, is when there's little or no resistance. So let's say there's a bunch of buddies, like a usual electric charge should have. And let's say there's many paths to the mall. There's a bunch of them. You can go into many stores, and you have to get from A to B. But there's so many of your buddies that they all there's no resistance at all, so they go very quickly. Some of them go here, 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 and some of them just go into, let's say you're not allowed to go past here. There's construction going on, and they go right past there. And then they hit something, it falls, and there's a big explosion. Right there. Let me change the color to orange. A big explosion there. Right here, he bumps into the emergency button. It starts sprinkling everywhere. So we have some water coming out. So now there's a fire, water going on. Everything is going badly. Only a couple of them got to be. But if there were resistors right here, if there was a bunch of shoppers going on here, the circuit or the current would have stayed here. So our buddies, let's say right here, would have, let's say this buddy, you would have kept moving slowly and not have diverted and got to be properly. In electricity, this can happen and be pretty bad, because let's say there's a component you can't have electricity touch. But since it's going way too fast, uncontrollable, it just ultimately goes there and touches it, and everything goes badly, like we saw with our mall. That is basically short-circuiting. So today we learned what the battery was, what loads were, what electric current is. We learned some examples, we learned what a conductor is, and electrical resistance. Okay guys, thank you for watching this video. I really appreciate it. Leave some comments for next videos I should post on this channel, and leave a like if you liked this video. Please subscribe for new videos like these and encourage me to make more videos with new ideas. Next video is on voltage. Thank you for watching. Easy Science out.